Hey, what's going on, folks? It's Mike here, and welcome to the next lesson in our modern C++ series. In this lesson, we're going to continue looking at the STL sorting algorithms. And there's actually a really handy operation that you might know. It's called merge and in-place merge. Of course, you probably learned this in the context of merge sort. If you haven't learned that, today's a great day to practice implementing your very first merge sort. We'll follow along with the CPP reference example, but let's go ahead and take a look here on CPP reference, our favorite website with all these cool algorithms in the standard template library. So go ahead and take a look here, and I'm going to go ahead and scroll all the way down here. And previously we were looking at the sorting operations here. So we looked at sort, partial sort, nth element, and so on. So make sure you're subscribed, or otherwise check out those lessons in the playlist or on my website here, courses.m.io, so you can track your progress. But the point is, we're going to look at these operations here that work on sorted ranges here. Okay, so let's go ahead and open up a merge and in-place merge here. Now, the difference between these two is in-place merge does, well, a merge of two consecutive sorted ranges, which indeed means if I've got some values like this, 1, 3, 5, and another range here, 2 and 4, for instance, these have to be sorted, right, in some consistent order. Okay, so the default order is sort of looking at each element as less than the other one. But it'll put these together as 1, 2, 3, 4, and 5 here. Okay, so get all of our elements merged together. Okay, so that's the idea. And merge sort, if you've ever looked at the algorithm, it sort of takes a collection like this, breaks it into smaller components until you get down to, say, one element, and then it remerges these together, sorting them in order here. Okay, so get your two elements and then ultimately, etc. Okay, so that's the way merge sort sort of works here. And let's actually do it. Let's see how merge works here. Now, again, it is important that the ranges are sorted. Maybe we should see how this breaks or what happens. And I'm really just going to use, I guess I could get away with either merge or in-place merge here. But looking at both of these briefly here, actually in-place merge has sort of the nicer, looks like the nicer interface here. And this is actually getting some updates here. This is kind of cool. Const experts in C++ 26. So our first time in this series to record that we can reference something in C++ 26 here. Okay, so that'll be for const expert stuff here. Okay, some updates coming here. And let's go ahead and see merge here. So the differences here. So again, we've got some const expr versions of this, but this takes forward iterators, okay, from the first to the next range, and then so on for the next range where we want to merge. And we've got to decide where do we want to output all of this stuff here. Okay, so that's sort of the difference. In-place merge is going to be a little bit easier to work with. It's just going to try to allocate a temporary buffer for us. I believe somewhere it says that here in our notes. Yeah, the function attempts to allocate a temporary buffer. So you could get an exception or something if you don't have enough space to allocate things. But this one here, we need somewhere to output things. Let's actually just look at the example here. Let's see. So again, if I've got two ranges, V1 and V2, that are sorted, again, I can take the whole of that sorted region, the whole of the next sorted region, and then I choose my destination here. Okay, so that's the difference with merge here. Now this one, let's do both of these. We'll go ahead and just take a look at both of these. So let me give myself a clean example here. Here's from the previous video, nth element. So be sure to check that out, but let's go ahead and shut that down. And we'll work from a nice clean slate here. Okay. So let's just go ahead and create two vectors. I'm going to use class template argument deduction, so I'll just pick up the values here. And let's go ahead and put in some randomness in here just to make it interesting. Let's make these more even numbers. They could be negative though. -4, 6, -8. And let's go ahead and make it v2. And we'll go ahead and say if v1 or if is sorted v1, or let's say not is sorted, then we'll go ahead and run our sort here. And we'll just use sort v1 from the beginning to the end. Okay, So again, just practicing using some of our building blocks that we've seen in some of the previous videos here. And we're going to want to do the same thing here. Maybe we want to write this as a function here. I'm just going to call this sort, and let's just take in our container here. Let's take it in by reference as well. We are going to want ints here. Here, I'll be specific just to make sure we don't get longs instead of ints here. I don't want too many conversions coming in, but we will pass it in by reference here because we don't want a copy. But that way it'll do the check first here. Okay. And I'm just going to call it, let's think of a good name for this, like check sort. Checks if sorted, otherwise sorts. Okay. And you could return a value or something. There might be fun ways, actually. This might be a great thing, too, to try to make const expr. So if you do have collections like this, it can try to do things. But anyways, that'll be the idea here. Okay, so we avoid... although if I say check sort, I probably do want to return a bool or something. I'm just going to say do sort. Okay, or maybe, yeah, I guess check sort was okay. But just some things you might want to think about with naming. I tend to think about those things a little bit longer here, but for the purpose of this video, I think that'll do the trick here. Let's go ahead and see if that is good for us so far. See if I made any mistakes here. Give that a compile. Whoa, you know, a whole bunch of stuff here. Let's see what we're missing here. And classic, you know, gotta put in, you know, we're expecting 3 arguments here. Let's see. Is sorted. We need the whole thing. This is where ranges are going to help later when we get to ranges here. Because then you can just put in the, you know, the collection, and it's going to look from the beginning to the end by the default here. Let's see if that got rid of some of our errors. Yeah, probably got some of our errors. And sorting, let's see here. Got to look at sort. And I should be able to just pass in the first and the last here. Okay, that seemed fine here. What did I do here? That's wrong. Expects 3 candidates. Okay, I could provide a comparator here. Went kind of bonkers there. Let's go ahead and explore our error message as always here. Might want to actually just provide the comparator. Maybe that's the issue here. Let's see. No matching function for call to sort. Okay, unresolved overloaded function type. Okay, oh, that's kind of interesting here. I wonder if it wants a comparator here. Shouldn't have to. Should be using default less for an int here. Let's see here if that calms things down here. Nope. What's the issue here? Let's see for a second. I guess it's just not happy with these guys here. Begin and end. Once more the generic version here. It's kind of interesting. Kind of strange. But anyways, okay, that gets us sorted here. So something to try. And we've been a little bit specific. Now, if I specify this for my comparator, I should probably specify it here, but I'm just going to get rid of that. And we're just going to go with the default rule here. That's probably something we want to put in our check sort function here. But anyways, we get the idea here. And let's just go ahead and write another helper function here. I'll go ahead and put it up here called print collection. We've done this in a few videos now. Take in a vector. And this one's going to be const because we don't want to modify anything. And we're making it generic, so I'll just call it C or something. And for each of the elements here in our collection, we'll go ahead and write them out. And I'll just go ahead and put the element and maybe a space after and a new line at the end here. Okay, and then let's focus on the important part here. We'll check if they're sorted, and then otherwise print out our collections, v1 and v2. Okay. And let's go ahead and give that a run here. Whoops. But every time we compile, we'll go ahead and run. And we can see we've got these collections here. And we've got v1 sorted because it ran through check sort. And this one's unmodified, but we can see that it's printing out fine. Okay, so let's go ahead and let's sort both of those because that's what we've got to do for our merge here. Okay, so now let's actually get to our merge here. Here it is. again, both of our collections have to be sorted, and basically it's just gonna, if you imagine how this algorithm's gonna run, is it's gonna look at v1 and then v2, compare the first elements and kind of pick them off one at a time here, and then move a pointer or let's see, I think this is taking in some input iterator. Okay, so it could be a pointer, could be an index, depending on what type of thing we have here, and then just compare the next element until we're at the very end. Okay, so that's the idea with how merge is going to be implemented. So let's go ahead and let's just call this results here. And again, you could do all the fancy things that we learned about. We could reserve for result the size of v1 and v2 to make this a little bit quicker. Just something for you to think about here. But let's just go ahead and check if they're sorted. We're going to do our merge from v1 beginning to v1 the end. The same thing for v2. We want to look at the whole range here. And then we're going to do a back inserter to push to the back here of our resulting collection. And we'll go ahead and print out that collection for our result. Okay, so that's the idea. Oops, let's see. Again, what did I miss here? Always a standard merge. There we go. All right, so there we go. Are we in order? Well, you know, each of our individual collections was in order, so nice and easy there. And then we could see, based off of our default rule, which is looking for things in ascending order here, everything's in order here. So nice, we've got a nice merge collection here. So with that said, let's go ahead and look at the results of our in-place merge that we can do. And that makes things a little bit nice. We don't have to do the allocation here. Or rather, Vector's handling this for us, but I believe the in-place merge, it does the temporary buffer for us. So if you implement something like mergesort here, it'll just do the in-place merge for us. So from the, and let's go ahead and try to understand this, because it's a little bit different, I suppose, here. But we're merging two consecutive sorted ranges, from the first to the middle and the middle to the last, into one sorted range here, okay? Okay, so let's go ahead and think about that. So since this is happening in place, sort of in the same data structure, okay? Okay, and how we can sort of show this off here. I mean, merge sort, I'll actually leave that as an example. That's a good one for you to do here. Let's go ahead and just show off in place merge, okay? And let's go ahead and set up another vector here, something like this. Okay, and we're going to go ahead and let's give ourselves a little bit of space here just so we can move things around. Let's call this V3, and let's go ahead and just give us sort of one, well, let's give ourselves some random numbers, something like 5, 7, and 2, and 9, 6, and 8, okay? So I'm going to sort of treat this as the first half and the second half here. And what I'm going to go ahead and do here is let's use partial sort, which is going to look through the entire range, but just sort part of it here. So V3, let's go ahead and make sure we don't get trapped here. At the beginning here, beginning of V3, now we got to think here, is it +2 or +3? +3 for the beginning. 0, 1, 2, 3. So that sort of goes as the middle. And then we need to look at the whole range here, okay, to do the partial sort. And let's see, does partial sort return us anything? Can't always keep all this in my head, which is fine. That's why we have CPP reference. Let's see, yep, just void here, okay. And let's see what the middle element is here. Rearranges elements such as the range contains sorted middle minus first, okay. That might be a +2, we'll have to just see here. Let's just print out the collection though. Right, so we should see 2, 5, 7, and let's just make this like 5. I'll make that 6, 9, 8, something like that. So I should say 2, 5, 7, and then 6, 9, 8 if this works as expected. Okay, V3. Okay, give that a run. 2, 5, 6. 7, 8, 9. Oh, went one too far. Yeah, should have figured. Off by 1 error. Our middle iterator, then move one element and then a second element. Okay, so that'll sort the first 3 for us. Okay, 2, 5, 7. So partial sort there. And then we'll want to sort these ones here. Now let's make these negative here as well. Again, just to show that they're out of order here. Okay, here, let's give ourselves a little new line here, right? Just so you can see that we're doing the sort of partial sort here for this collection here, okay? The first half, second half, I guess it's a little bit misleading here. I'm just taking the, oh, I guess I was right, but the first 3 elements here, okay? Never doubt yourself, give yourself different examples, there we go. So again, partial sort works by looking at everything and just returning a collection that has, this range of things in the sorted order here. Okay, so there we go. That's looking better here. So I want those sorted, and then I'm going to want these sorted. The second half here. It's my beginning plus 4 to the end. And let's go ahead and see here. We should get something -9, -8, -7. 7 to 5. Oops, gonna still be an off by 1 error here. I gotta play around with that a little bit here. Okay, now that's looking in sorted order here. Okay, so that's one way that we can work with this to get things sort of in a sorted order here by using this partial sort. But what I want to do here is with in place merge is actually let me just demonstrate this as partial sort for 2, halves at a time. Yeah, I guess to give us a similar result, but with 2 halves that are sorted here. This will make it a little bit clearer if we go ahead and do, let's go ahead and do V4, and I just want one side that is sorted. And this other side here is also going to be sorted here. -1, -3, -2, -1 here. And I want to put these together so that I get, effectively, it flipped here with the in-place merge. Okay, so let's go ahead and do this with V4 here. I just have to be able to identify the middle, okay? So I'm going to make my best guess here, again, with begin 3 here. See if I get it right here. In-place merge. This is our, oops. I'll go back and walk through this again if it's going a little bit fast here. But the in-place merge, and, well, I want to start from the beginning here. Now, again, picking the point here that's kind of the pivot that tells me, yeah, this is one side that's sorted, this is the other side that's sorted, but in place, basically it's going to be doing swaps between these, right? If 1 is less than -3, it'll swap here. Okay, so -3 should swap effectively, and we want to keep track of, well, -3 is that less than 2, or excuse me, -2 is that less than, whatever the next value is, and do a swap. So begin V4 plus 3, so I think I get the right index right. V4, we'll find out if it comes back sorted, and let's go ahead and print out our collection. Handy function here. Okay. And do we get things in sort? Yes, we do. Okay. So -3, -2, -1, 1, 2, 3. Okay, brilliant. Okay, so let's go ahead and do a little bit of a recap of this video and try to understand, again, all these things that we put together. So we did a little helper function first, just to print out our collection, and then put together some of our sorting stuff just to check if something's sorted. If it's not, sorted. Okay, so simple enough stuff here. So we ran that here. And the purpose of why we were doing that is because both merge and in-place merge are useful functions for taking 2 already sorted collections and merging them together. So if those are totally separate collections, we've got merge, which we put together 2 separate vectors here and created a result. Okay, so it'll write out using some output iterator to some new collection here. Okay, so that's important, and we use this back inserter. And then I showed with partial sort how if I have everything, in one collection, and I sort of have 2 different halves that I can sort. I mean, this is actually a little bit different because partial sort's looking through the whole collection and just saying, yeah, I'll get this, half in sorted order, and then we can, sort the second half in sorted order. Or the other way to think about it is just say, yeah, put the first 3 things in the entire collection in sorted order. And then this is saying, okay, yeah, look at the last 3 things and make sure that those go in place in the right order here. Okay, so this is sort of related to this idea, but here we just have one function that says, okay, I know the first half sorted, and here I know the second half is sorted, right, by the same rule. Okay, so in ascending order here and here, but I can sort of think about those as independent collections and then just in place, basically look at these and compare 1 to -3 and say, okay, -3 should come first, and then I'll compare the next element that's not in order, 2 and 1, maybe do a swap here, and then I need to compare that with the next thing and the next thing and so on to get things in place here merged. Okay, so that's the idea. Hopefully that makes sense. If it doesn't, I think implementing merge sort or going through that is a nice example. So anyways, with that said, that takes us through a lot of the different sorting operations as well as some of these other operations here. And eventually we'll get to ranges and stuff, which makes these even nicer and easier to use, which is great. All right, so you can go ahead and check out, make sure you've done all the different sorting videos here. You can track your progress on courses.mshot.io as always. And if you've enjoyed that, if you've used these for different operations, I know I'm showing you with sorting and kind of classic things because that's how to think about it. But again, maybe you've got a set of custom objects that you've had to merge into one sort of list. I think that'd be interesting. I'd love to hear about it in the discussions below or share with the community. Otherwise, I'm sure other folks would learn from it. So anyways, folks, with that said, thanks as always to those supporting the channel who are subscribed or otherwise members. I appreciate that and hope you're enjoying learning here with me. Alrighty, folks, with that said, I'll look forward to seeing you in the next one.